Thank you so much, Cliff. That was very, very insightful and informative. So now we like to welcome the panel to the panel discussion on the financial future of distributed solar. I'd like to open up with you, Stephanie. If you could tell us a little bit about CHESA and the biggest challenges your members face.
Yes, thank you so much. So CHESA members are distributed again across our region. So members in Virginia and Maryland and DC all face different challenges, but I'd say for rooftop solar costs, especially unexpected costs, can kill projects. So the ability for these installers to be able to reduce costs in any way, especially through the implementation of new technologies, would be huge for us.
Excellent, excellent. And to the other members of the panel, do you have anything you could recommend to Stephanie and her association on how to reduce these costs?
So Solar Success is literally designed to help reduce those costs by bringing in the project management and accounting together, and then bringing in this next, which is fundamentally focused on installation. So bringing in the next phase of monitoring these assets as we grow our install base with the Soltell Systems, which we've evaluated as the lowest cost way to bring that benefit. We are super excited that we're going to be offering that for your members.
Great. Leon, anything to add to that?
Actually, I have an insight from another angle. I think we have to look at what is happening in the US over the past year. There has been a plunge in utility scale installations, but on the other hand, we see record installations in residential solar. And it shifts the focus from large scale utility scale development to residential scale, which is essentially key to achieving the targets which the government wants to bring with the renewable energy deployment. And to achieve those targets, essentially, we need to bring down costs. So we know, the hardware went down with costs by a pretty large margin over the past decade, but we are beginning to hit the floor, at least in the short range, with supply problems, etc. But we have to be looking into the soft costs of system planning and installations. And I think this is a very common language we're talking with Jan from Blu Banyan and with Dr. Clifford, that there are ways to reduce the costs in the system lifetime. And this is essentially a look into the future, into this decade, what would happen towards the end of 2020s.
Thank you.
And my hope is that by reducing these soft costs, we actually bring the total addressable market for residential solar down. Right now, you need to have an income of about $96,000 to take advantage of the individual tax credit that is offered by the US government right now. And by reducing the soft costs, we can actually extend that benefit so that the effect of the benefit reduce the effective cost to people that would get down to about $70K a year. That would be a much larger market for CHESA members to be able to deploy solar to, and it would be a much more equitable solution altogether for our country. So reducing soft costs can, with it, because it's about 30%, it's actually can be equivalent to the ITC level benefits, and it can adjust that for the market.
Excellent. So that applies to the US market.
The US market, yes.
Primarily, yeah. Cliff, anything to add?
I work in research and speak frequently with operators of distributed energy grids. They actually don't use much of the data that they could be using from solar power systems due to the cost of being able to acquire, interpret, perform quality control. Much of that's related to the fact that the data is in a bewildering variety of formats. And so I'm encouraged by development of things like this taxonomy and seeing its use on the business side, that it could ripple through and have side effects on the operational side of electricity as well.
Yeah, that makes a lot of sense. So Stephanie, did that this the panel answer your questions? Do you have anything else to ask or add to it to clarify?
No, I think everyone made very good points. I guess solar installers would be interested to know how quickly this kind of technology could be implemented to impact their bottom line.
Yeah.
So solar success typically takes 90 to 120 days to get implemented. And but it's you're changing your accounting system, your operational systems, and then you begin to integrate throughout the ecosystem. So it takes 90 to 120 days to get started on the path. And then as each of these become available, it becomes an ongoing journey to get the best of breed. The ROI on these effects, adding that continuous improvement, however, compounds and has been staggering to observe. So we continue to see very large growth rates for residential, commercial, and utility scale companies, which will continue to maintain the effect. But it is a substantial competitive advantage to have these soft costs reduced and these errors removed.
Excellent. Thank you for that. I'd like to move on to Leon for a moment, and wanted your perspective on, what's the future of these solar performance assessment technologies, and what is driving the trend?
So I've already mentioned that we are beginning to see a kind of shift in the US from focus on utility scale to focus on the centralized scales, especially the residential one. And this seems to be the look into the future. Now, the situation in the world is like 62% utility scale and 38% decentralized is not reflecting an individual country. So in US, it's about 60-40, about the same range as average in the world. But for example, in China, is almost entirely utility scale, while in Europe, we see decentralized being way more adopted. So in Germany is way more than 50% already. So I think that we have to be looking into ways to make utility scale better and also to make decentralized better. So utility scale has its own, advances. We've been approached by a number of companies in the industrial scale trying to correct the performance ratio with temperature correction, but that's not actually what we are expert in doing. We have other performance indicators developed, which are even better than that and applicable also for both residential and commercial and community scale. And we see essentially these techniques reaching very high level of accuracy in performance assessment being adopted for distributed as it grows. And I think it's undeniable that it would grow in the US to a much larger extent, like way more than 50%. I'm coming from Israel, so now the situation here, it's 55-45 in favor of utility. The plan is to reach 80-20 in favor of decentralized. This is a very big change. And this change will probably be coming, obviously in Europe, with the adoption of mandatory PV on public buildings and later all new residential buildings, already happening in California. I think the rest will follow.
Yeah, excellent. And so what do you see as a difference between this utility scale and decentralized PV in terms of these future trends you spoke about in the performance assessment?
I think utility scale will have to make small corrections and small advancements. So there is more software being available for asset management with more precise algorithms. I've recently been at a seminar with one of such software providers. It is made more accurate, but it's like between the difference is between moving from 4 or 5% accuracy to 3-4% accuracy. That's the play in the utility scale. In the decentralized scale, the difference is huge. It's like moving from 15-20% accuracy to what we can offer, or at least like remote sensing. So 5 to 10% is already available, and we are making accuracy of 2 to 5% available already. So that's something which will totally change the situation in decentralized PV. both in terms of operation and maintenance, but also in terms of financing and financial reports. That's my opinion.
No, that's a tremendous game changer, and its utility in the industry. Dr. Cliff, I wanted you spoke about the new standards, so I just wanted to get your perspective on how will the solar industry businesses, installers, contractors, developers, financiers, feel the impact of these new standards and implementations that you spoke about?
Well, perhaps not directly, but certainly indirectly through the services and the tools that they acquire to operate their business. If adoption of a common data standard makes, say, their inventory management software talk easily to their sales software, that would reduce, of course, the installer and developer's cost for making the sale. And I think those savings trickle all the way down through the solar economy to the end user, to the owner of the system that's being installed.
Mm-hmm. And I would like to touch upon another point. You have been involved with the PV Lib Python toolbox. Can you share a couple of insights on what it does, what it provides, and how it simulates? How its simulations help the industry?
It is a library, and it's in Python, and there is no user interface. And that's deliberate. What we intended to do was to provide essentially a toolkit that other people could build applications on top of. We are committed to documenting the best-in-class algorithms that are coming out of the research and the engineering community, making those readily available to those who are making products for the solar industry. The purpose of that library is to accept weather inputs and produce accurate estimates of power output from a system based on its design specs. There are companion libraries that aren't as mature that are intended to deliver best-in-class algorithms for example, doing data quality control, for recognizing features in monitoring data from solar systems, such as inverter clipping or cell shading. But it's something that myself and my colleagues at different laboratories feel passionate about. And this is one of the most effective ways that we can deliver the results of our research to the community at large.
Nice, that's amazing work. Yeah. Yes, Jan, you want to say something?
So Cliff, would it help you to be fed data from actual operation of systems that was done in a consistent way? Are there any plans?
Absolutely. You would think after 12 years of doing this that I'd have a giant disk full of data from PV systems, but actually it's hard to obtain that. You have to get beyond the concerns about the data being proprietary first. But then once you get it, you realize you're back in what you described as spreadsheet hell. I've got a spreadsheet that has mysteriously named columns. I have no idea what units are used. Sometimes the times are not recorded with time zones or so you don't know if it's accounting for daylight savings times. You have to discover this by looking at the data itself. And it would greatly facilitate the analytics that we want to develop and deploy, having consistently labeled data.
I suspect that is also the experience of every owner and all of these utility scale assets, and then down from that scale, that they also have these exact same problems. So we solve it for everyone and get better input to you to give us better models altogether.
Yeah. And that's a great segue for me to ask you this question, Jan. So you spoke about solar success and its ability to streamline operations for residential, commercial, utility scale solar installers as well as developers, which will help to scale their business profitably. Can you share some real life examples of how this application has impacted major commercial or residential clients in your business?
Sure. The metrics that we look at to determine how efficiently a business is running is pretty much looking at how many watts they have per employee. So, because everything gets put into a price per watt. So how much overhead labor do you need per watt in order to run a project? And what we have found is within 90 to 180 days, the overhead labor costs are reduced by 3 to 5 cents a watt. That just means pure throughput. It takes fewer people to run more projects. And with that, you've got all of the HR issues and the quality control issues, all of those things go down, especially as it's really hard to find high caliber people right now. So that has been a huge direct, measured impact for how we do that. The other key metric that we're looking at, because we want to deploy more solar faster, is how much solar are you running? So this is the number of jobs, and we reduce the overhead costs of that. But we also want to make sure that we're deploying it faster. So we're looking at how long it takes to get, a project to cash, because you'll typically have up to 4 milestones in residential projects. You can have many more in commercial projects and certainly utility scale projects. But we want to see how quickly you can move between each of those milestones, because having a solar on the roof that still doesn't have PTO isn't doing anyone any good. So we need permission to operate. You actually need to get all the way through to the end and across the finish line before you start, doing the good that was intended. So that is our next, the next key metric that we look at when we're establishing the kind of baseline health of a solar installer company, and then watching them grow, and as they make changes, showing how those changes are benefiting those two main metrics.
Yeah, thank you, Jen. So Stephanie, in your view, just what Jan shared, how do you think this would impact the members of your association?
Yeah, I think for the residential installers, this could be very impactful. Letting them understand how easily it can fit into their business operations, I think, is key, so that they can better plan for their projects and have this integrated as they're figuring out how much each project might cost.
Excellent. Great. So we're almost on time to wind up this panel, but I want to leave with asking each of you to share what is one key insight or takeaway that you would like to leave with this audience. So since you're on, I'd like to start with you, Stephanie. What is one key takeaway or insight that you have?
I would say my key takeaway is that solar is extremely important, and there are a lot of forces that are working in our favor. But if we can't streamline, if we can't make projects as economically feasible as possible, then we'll continue to face roadblocks in the implementation and deployment.
Thank you. Leon.
I totally agree with Stephanie. I think that we have like two things shining up in the future. One is mandatory solar, which is very nice, but making mandatory expensive decentralized solar doesn't make any sense. So we need to work to make this thing cheap and available on any scale. And that's, I think, what everyone should be concerned about in those days.
Thank you. And Cliff, what is one key insight takeaway you would like to leave with this audience?
Absolutely. The value of open source development and a diversity of voices participating in that, I think, has promised to create a data language that's going to benefit the entire industry.
Great. And over to you, Jen.
So the oil and gas energy infrastructure took 120 years to make. We are trying to redo that energy infrastructure in 30 years, 4 times faster than has ever been done in the world. We will only succeed if we establish the energy information infrastructure at the same time. That is the key to being able to successfully deploy and coordinate that much infrastructure that fast.
And on that note, I'd like to thank the panel for this fascinating discussion. We have 4 minutes more, so I'd like to go to some questions. I have a couple of questions which has come in, and it's for the panel. So in this presentation, you referred to, the CNI and the community solar needing this sensorless algorithm solution. What about the residential PV market? would they need this? Would it make sense to them? Would it be cost, what are the cost benefit of of implementing these new measurement performance metrics?
So absolutely the residential needs it as well. The large commercial has an immediate direct decision-making process. The residential owner, it's a more distributed decision-making process because there's just a lot of smaller systems in what they're doing. But the clearer and the recommendation that we can make with greater confidence, that will be the key to doing better O&M, to establishing basically our residential distributed solar energy base. And since it is cost effective, it does work well for residential. It will be a behavioral shift for that particular market. Leanne, what do you think?
So residential is a tough market to work with. Essentially, since we do not work with end users, we work with either integrators or software providers in the asset management world. So the residential is not the immediate need we found. So we found the need in the commercial segment, where the problem is truly bothering a lot of companies. And indeed, for example, today we work mostly in the small and medium commercial scale, but we already started working on residential scale. I think around 50 facilities of residential already connected to our systems. And this provides pretty solid evidence that this thing also works for residential, and provides also things which like residential owners and operators and integrators haven't thought it's possible. Like, how can you know if you need the soiling cleanup in a residential facility with an accuracy of just 2-3%, and then you can time the cleaning, and then you can make predictive maintenance, you can optimize the cleaning schedule. So those things are unheard of in the residential world, but they are in fact possible. We are already discussing the possibility to apply this to larger clusters, to thousands of systems, and I believe that would be in the near future.
One more point that's occurred to me about this, Andrew, is that in residential, the cost of customer acquisition is really high, because then it's very difficult to justify an ongoing service contract because we don't know what these monitoring and performance systems are. So with the sensorless technology and the improved certainty of needing O&M service, this may be a mechanism where we can increase the lifetime value of the customer on the residential side, which would be a substantial stabilizer to our existing solar installers and give them that, broader business base to continue to function through the twists and turns on the solar coaster life.
Great point. Great point. So I have time for just one more question, and this just came in. So for Leon, and maybe Jan can also jump in. So Leon, how many installations of this solution do you currently have? And has it been integrated to the monthly operating reports already? When could we see it?
So we are now transferring from managing hundreds of facilities with our sensorless algorithm to thousands. And we are working right now with Jan's company on integrating our tech with their solution. So our initial plan was to see it taking place by the end of September. And this is where we're aiming at.
Thank you very much. That's all we have time for. Jan, sorry, you had a last minute.
That's great.
Okay, thank you very much, everyone. Thank you to all those who've attended. Thank you to the panel for your time. And look out for an email from LNRG for the link to this recording. So have a fantastic day and have a fantastic weekend. Bye-bye.